Rustam Stolkin from University of Birmingham, and I'm here with my colleague Peter Schwabach of Shield Investment Management. So RoMaNS was about sorting and segregation of nuclear waste, and the partners were Technical University of Darmstadt, CEA, the French nuclear agency, CNRS, and the UK National Nuclear Laboratory. And I'd just like to start with a couple of questions. You know, what sorts of applications should we be looking at as roboticists? And I would say it would be nice if we can find problems that can only be solved with robots and can't be solved any other way. It would be nice if these problems were societally important and economically very large, and also if they were urgently needed now, okay? And I'd also just like to say something about tech transfer in industrial commercialization versus doing academic research. And I'd like to suggest that there is no conflict. And when you actually start to look at these nasty, dirty industrial problems, you find that they're extremely challenging intellectually. So this is what nuclear waste looks like. The cost of cleaning up the UK alone is estimated at nearly 300 billion euros now over the next 100 years. A large part of that can only be done by robots, and the robots haven't yet been developed sufficiently to do that job. Also, if you look at heaps of garbage, how do you get a vision system to make sense of that? How do you manipulate deformable objects like rubber gloves and respirators and hoses? You can see that it's very, very challenging. These are some recent trials that have been going on. This is very, very realistic fake nuclear waste, and there are experiments to see whether it can be handled and processed by these large KUKA robots. They're taking in these large oil drums from the 1950s that nobody knows what's inside them. They have to be cut open, all the waste tipped out and sorted and repackaged into these modern stainless steel boxes on the right. And we'd like to separate the highly radioactive stuff from the less radioactive stuff because we don't want to fill up the very expensive storage containers with the low-level waste. That's why this project was called Robotic Sorting and Segregation. These videos are massively speeded up if you look at the clock. They're all being directly teleoperated with a joystick with very limited situational awareness, looking through TV cameras. So the robots have to go very slowly. There's nothing here that we would recognize from a modern robotics research lab. So no autonomy, no telepresence haptics, no compliance force control. It's 1970s technology, essentially, in terms of robotics. So we wanted to see how we could help this, and we had three main approaches. So the top right is the work by the robotics lab at CEA, and they've developed a really state-of-the-art master-slave system with haptic feedback, a novel haptic exoskeleton hand, and on the left, a novel compliant slave robot that can behave compliantly, a bit like a KUKA lightweight arm, but with actually mechanical solutions instead of electronics, so it's nuclearizable. The bottom left is the work of my team at Birmingham, where we do a lot of autonomous robotics, so this is fully autonomous vision-guided grasping. And in the middle, on the bottom right, the haptics and teleoperation come together with the autonomy in a shared control system where the human and the AI are collaborating to control the remote slave robots. So very briefly, to summarize where we got to by the end. So top left, CEA had a fully bimanual haptic master-slave system. On the bottom, we have both autonomous grasping on the left and a shared control system on the right. And this is not with actual radioactive waste, but it's implemented on a nuclear industry site, and that's subject to full nuclear safety and national security regulation. And getting things into that site was actually, I would say, harder than doing the clever robotics. but that's with nuclear waste simulants, so it's not radioactive. The top right is laser cutting in a real radioactive environment, and that's the first time in history anywhere in the world that anyone has ever allowed a robot to behave autonomously in a real radioactive environment. So that's a computer vision guided, AI controlled probabilistic path planner cutting real contaminated steel in a radioactive environment. So when I say autonomous, nobody knew what movement the arm was going to do before it moved. Okay? So that we're very proud of. And just before I hand over to my colleague, these are some of the innovations that came out of this. We had new robot arms and hands developed and turned into spin-out companies. We worked with Kuku UK on to industrialize the autonomous grasping, and this project then attracted venture capital investors, and I'll hand over to my colleague Peter to talk about that.
So first, let me introduce myself. I'm Peter Schwabach from Shield Investment Management. We are venture capital investors in new technology. We have a fund in the UK, and we're sector specific. We invest in robotics and in AI companies. Our relationship to Rustam, we met him through his work at RoMaNS, 2020. And our interest is essentially to look at the applications of work being done in the nuclear industry and how they can be applied to the SME market. So one of the things that's very clear about the different markets, if you look at the period it takes for a product to come to market, if you look at the nuclear decommissioning market, it's, our own estimate is probably 12 to 15 years. Essentially, 6 years of R&D, 6 years of testing, potentially deployment. You then go down different industries: defense, oil and gas, mining, and then manufacturing. And our interest is essentially deploying technology that's being developed at Birmingham within the SME market as quickly as possible, because essentially the challenge of doing manipulation and cutting and moving, which is taking place in test facilities in the nuclear decommissioning market, it'll take 10 or 15 years to get that approved and health and safety, whereas actually the technology is immediately applicable within the manufacturing market. So if you look at how money is being spent globally within the AI and robotics market, the largest amount of money is going into the manufacturing sector. So in 2017, it was about $16 billion in terms of new robot arms and AI. And so we as investors are very keen essentially to adopt cutting edge technology which is being developed at universities and applying it into the market. So we're very interested in a long-term play in the nuclear industry, but actually we believe the technologies being developed have immediate applications in the manufacturing market. And we have a particular interest now in the SME market, simply because the price of the technology in terms of the arms and the software has come right down, so that your average manufacturer of sausages or spaghetti or small components can actually now say, actually, I want to adopt this technology. And essentially what we do is provide a bridge between what's happening in the academic world and what's happening in the SME market by backing companies that implement that technology. So we're very proud to be working with Rustam. He's, the team he has in Birmingham is extremely pragmatic in terms of adapting those technologies to the commercial market. And we've seeded a number of companies with members of his team, essentially to deploy that technology. So we're very glad you supported him because we get the benefit of that. So thank you very much. If you have, if anyone here has ideas they want to develop in the market, do come and talk to us. So thank you very much.